Good afternoon, dear students. Can you hear me?
Yes, Hojam.
Okay, Zahban. Thank you. So then we can start. As I already announced, so from today onwards, we will continue our lessons on Olon platform. And if there is another decision, let's say if we decide to do the lesson face to face, then I will inform you. So as long as I don't inform you, so we will continue using the Olon platform. Okay. Okay. So today we will continue with.
Hocam.
Is that a question?
Yes.
Görkem, buyur.
Hocam diğer dersler hakkında bilginiz var mı? Sadece siz mail attınız da normalde 20'sine kadar tatil gibi anlamıştık biz.
Tatil değil aslında. Günsel Hoca ile görüştüğümüzde hocalar isterse Olon üzerinden yapabilir. Aslında o şöyleydi. Actually, the decision was the universities will not will be closed till 20th of February because of the earthquake. But later they decided the university has to continue with distance learning. So therefore, the first decision is not more important for me and also for the university. So we will continue our lessons not only 1 week, maybe some weeks, I don't know. But for the time being, decision is the lessons must be continued with distance learning. So therefore, we start from today. Okay. So I have a problem actually with the other group, that means with the mechatronic engineering group. So there is another lessons joined to this course, the name is instrumentation components and instrumentation of the mechatronics. But I don't know. I will discuss today with the authority how can we bring together. The two groups. There are two different lessons. They have also two different connections via the Olon platform. This is our only difficulties now. I'm sure that next week or this week I will solve it. Somehow we have to solve it. Okay, now, so what did we learn in our last lessons? Can somebody summarize?
We learned about actuators a little bit, I remember.
Okay.
And power transfer from not hydraulic, but pneumatic to mechanical, I think.
Okay. The converting the energy from, let's say, the electric to the mechanic, from the mechanic to the pneumatic, and the components involved in the converting of the energy we discussed, like electric motor and the compressor and the type of compressors, screw compressors or piston type of compressors. And then we start with the actuators, and we actually discuss the single acting linear actuator. We finished the single acting linear actuator, and we learned also the valves which we use to drive the single acting linear actuator, isn't it?
Yes.
So then, as I do today we will continue with double acting linear actuator. Actually, we shortly mentioned what is double-acting linear actuator, but today we will continue, and therefore I'd like to turn to the slides, and before that, I have to make some arrangement on the online platform, like moment. So then let's come here. Okay. Yes, I'm going to share the screen with you. Indication, segmentation, okay. Okay, so now I have to prepare the slides. Where is it? So it's like. Okay, and then maybe, sorry. So before that, I have to use okay, all Okay. So can you see the slides?
Yes, Professor.
Okay, thank you. So because if I share the screen, so I cannot see any, let's say, the message from you in written form. So I need to hear your voice for the communication. So, okay, then let's choose this one. Okay, so air generation, pneumatic actuation. Also, we discussed what is piston compressor and also on screw type of compressor. So the some components involved in the air production, like energy supply, compressor, storage, the drying units we don't talk about because it's not needed. It needs especially the people who really involved strongly in pneumatic applications. And the air distribution, that means pressurized air distribution, so we will not discuss too much, but let's give a brief information. Piston type of compressor, we already learned, you know that. And the screw compressor, also you learned, I have shown the video and discussed. And this is the air receiver. Here you see the air receiver, and this is the compressor. If we see the power unit, let's say power unit of pneumatic, here we have the compressor, and this is the air receiver or reservoir, and we have here some instruments on that, like pressure gauge and the temperature gauge and shut-off valve, and so on. And here water drain here on this tank, I mean the air reservoir. So air service units, and we will also discuss the air service units. The air service units consist of air filter, pressure regulator, air lubricator, and pressure gauge. And the air service unit is also important. Before the pressurized air flow into the machine. So and at the entrance of the machine there is service units, because the pressurized air has to pass first of all the service units and has to be brought onto the desired condition, then we use in the machine. So therefore the air service units consist of following parts: air filter to eliminate the dust and any particles we don't want in the air, and we need to regulate the pressure, and therefore we have pressure regulator. And sometimes we need to lubricate the pressurized air before let flow into the air flow into the components of pneumatic components in the machine. So sometimes we need the lubricated oil, and therefore we need lubricated air, and therefore we use the lubricator. And then the pressure gauge to observe, to check the pressure, to see the pressure value of the pressure. So, and this is the unit you see here, the quite complex service unit. And this is the entrance of the air here. The air enter into the service units, and from the service units into the machine. So here we have the valve, shut-off valve. That means we can turn on and turn off the pressurized air. That means the pneumatic energy. And this we can do by electric. As you see here, there's a cable, and there's a solenoid and solenoid actuated valve, that means. And here we have the pressure shape, this soft start valve. I guess this is a soft start valve. I cannot see exactly the symbol, and therefore after turn on the pressurized air, that means pneumatic energy, we need a soft start valve. That means energy has to flow, not flow. Let's say with a reduced speed into the system, and then we need the pressure sensors to check the pressure. So at any time to check the pressure at the entrance of the air at the entrance of the machine of the air. So then here we have the regulators, and here we have inside the filter, and here we have a cup made of glass. So it's a special glass. That means the air has some humidity naturally, and the humidity in the service units converted into the water and drain water, for example, and then we collect on the drain water here, or the water here inside of the glass cup, and then we can there's a screw here we can turn on and off, and we can take out the water inside of this cup. So this is so we don't have, sometimes we have here the lubricator, but we don't have the lubricator here. don't have the lubricator, but it seems I made a mistake. Yes, now I see that the pressurized air come from that side in. Huh? This is the incoming pressure, incoming pneumatic energy come from that side. So okay, and for this side is the air connection to the machine. So I guess they here they observe the pressure or can be observed the flow rate, and soft start valve and turn on turn off this manually. It seems turn on and turn off the pneumatic energy happens manually here. So here we have the regulator, and we adjust the pressure of the pressurized air. That means we adjust, let's say, to a certain value which we use in the machine, and this is normally 5 or 6 bar. And here we have the manometer to see the value of the level of the pressure, because we need it. So in order to adjust the pressure, so we turn left or right. This button here, and looking at the manometer or pressure gauge, so we can easily adjust the value of the pressure. Okay, so now you see one more, the air service units here. This is the lubricator. This is a simple one. You know, this is very complex. It consists of many items. I mean, these type of service units consist of many items, like pressure sensor or flow rate measurements units, or soft start valves, and pressure regulator and filter and so on. So this is very simple one. We have only here the air come from that side and go in that direction. You see here there is a arrow here. We can easily understand that the air flow in that direction. And also the lubricator has to be placed after regulator. This is the regulator. I mean, regulate the pressure of the pneumatic energy. So this is the indicator. I mean, the pressure gauge or manometer. So then here we have as I mentioned, there's a condensed water, as built condensed water coming from the humidity of air. So this water we collect here, or yes, we collect it in this cup, and then we have here the screw, so we can turn on and turn off, or if we turn on, so we can get the water out. So because we don't want that the air has humidity, but natural air has humidity. So therefore we use dryer, and also here in case of using the service units, some part of the humidity, a certain percentage, we can eliminate from the pressurized air. And there's a filter inside. We cannot see now here inside here. So this filter we use to separate the dust and any particles which is unwanted for pneumatic circuit. And you see the symbol here. This is there's two symbols. The one is this one, and the other one is this one. And these symbols are indicating the service units. That means the service units has a symbol, and this is the let's say the detailed one, and this is the abbreviated one. I mean the small one. And in the detailed symbols, we see all the components involved, mainly into the service units. First of all, this is the filter here. You see here this filter. It shows the filter. and here the condensed water. The condensed water we have to take out from here using a screw mechanism. And then we have here the pressure regulator. That means pressure, the valve to regulate the pressure. So there's a spring here, there's a arrow on the spring, and that means we can adjust the pressure. And here we have the indicator, I mean the pressure indicator, like pressure gauge. And then here we have the lubricator. So this is the symbol of the lubricator. And this simple symbol, we don't see all the details which we can discuss, which we discussed here, but it shows also there's a filter and the condensed water cup, and here the lubricator here, and the pressure regulator and the indicator of the pressure. And we see more about the service units. A service unit here, you see, this is the air come in here, so in that way, and this is the filter here in the middle. We can maybe can do so. Okay, so this is the air filter, and so on. The air filter actually is white, but I use the yellow color to make it clear. So this is the filter. Okay, this is the filter, and then air come from that side, and the under pressure. And if, let's say, the air particle arrives this cup, so suddenly the pressure dropped down, so fell down, and then the pressure, since the pressure, let's say, the fell down, so then the air, that means the pressure energy converts into the kinetic energy, and then the air gets cooler, and then the humidity content of air because of the cooling, so the condensed water built the condensed water, and we see the condensed water here collected in the cup, and then air, there's let's say the small gaps, many gaps on the filters, naturally. So then the air passing through the filter continue its way in that direction. So here we have and therefore we eliminate the dust, includes which includes air includes, and also the humidity we reduce because the humidity converts by cooling the air, the water which we can see here. So we eliminate a certain percent, we eliminate the humidity, we eliminate the particles which we don't like, and then the air passing the filter continue in that direction and arrived in pressure regulator. So this pressure regulator, there's a spring here you can see, and here also. So we can, using this spring, I mean, we can by rotating the small button, we can adjust the pressure, air pressure, and we can see the value here on the screen, so that the pressure may be 5 or 6 bar. So after regulating the the pressure of the air, pressurized air. So it continues in that direction, and we have here the lubricator. So the lubricator has to pass, let's say, the gap, very, very narrow gap. So then here in this part, the vacuum occurs, and because of the vacuum, say the oil here, there is some oil taken here into the direction, flow into the direction because of the vacuum occurs here, and some, let's say, there's some drop can be let's say it can mix with the can be mixed with the pressurized air, and from this point onwards, the pressurized air flow into the machine. So we use in the machine. So as a summary, we say there is some humidity in the air, pressurized air, and also some, let's say, the particles which we don't like. I mean the particles which we don't like in the air, we eliminate them here, and then we adjust the pressure of the pressurized air and check it here with the screen, on the screen, and then if we need, sometimes we need to lubricate pressurized air, so then we can adjust the lubrication using this lubricator. Then the air pressurizer is ready to use in the machine. Okay, this is the inside of the filter. Here, this is the filter. So again, you know, we have that we already use the yellow. I mean, this is the filter here, you see, and it's the filter, huh? Okay, this is the filter. Okay. Filter, so, and as you see, so the air come from here in, and then the humidity converts the condensed water, and the condensed water is collected here in this cup, and using this screw we can take it out because we don't like the humidity in the water. And then the air passing these filters, we eliminate the dust and all the particles we don't need. So then go in that direction to the regulator. So the regulator, how does the regulator works? I mean, the function of the regulator. You see the sketch of the regulator. So we adjust the pressure using this screw mechanism here. So if we turn, let's say, the right, so that means the screw can move in that direction. So, and then it press the spring here. So that means the spring will be pressed by the screw mechanism. So there is a deformation on the screw in one direction, that means in that direction. So the deflection. So this deflection times the screw constant, sorry, the spring constant, they give us the force. We can write like this. Let's use a sorry, not this one. Let's use the okay, something to write. So F is the spring force. Let's say the F spring force, F spring is equal distance, deformation distance, delta L times spring constant. Spring constant. And spring constant has the unit, as you know, what's the unit of spring constant? Do you know that? Newton per meter, huh? So, and this is, of course, meter. And if we multiply meter times Newton per meter, so we have here the Newton, isn't it? Force. This is the spring force. We can adjust by pressing or by changing the length of the spring, and for that we use the screw mechanism here. So that means we can change the force, spring force, like this by changing delta L. So we can change the force, spring force. So on the other side, you see this red one. This is the membrane. So on this side of the membrane, we have spring force here. Let's use the red one. So the red one, we have here the spring force acting in that direction. This is the spring force, Fs. Fs, this is the spring force. Okay. And on the other side, here we have what type of force we have here? You see, these force come from what? From the pressure. Pressure. You see, 6 bar is coming from here, and we have here the 6 bar. Let's say the pressurized air. And how can we calculate the force on that side? The force on that side, on the membrane here. This is total force. This is the F pneumatic or pressurized air. So the F pressurized air come from pressurized air is equal what? Pressure times, isn't it? Pressure, this is the pressure here. Pressure, this is 6 bar. And the area here. This is the area. And this area is like this. So, projection area of the membrane. Like this. Maybe it's better to I use the okay, this is red one. Oh, it's correct actually. Correct. So then that means P times A. This is the A here. So A, the area. So P times A. And what is the unit of A? Meter square, isn't it? So, and the unit of the pressure, Newton per meter square. So you shouldn't forget it. It's very important. And if you multiply Newton per meter square times meter square, so we have here the force Newton. So that means here we have two forces against each other, F spring and F pressure. So let's say in equilibrium, F spring is equal F pressure or F pressure. Okay. So then let's write instead of Fs, we can write delta L times C spring constant, isn't it? Then is equal what? Pressure times what? Times area. So what is constant in this design? Oh, sorry, there's a mistake. Delta L. This must be delta L. Okay, delta L. So here C is constant, spring constant. A is also constant because, you know, this area depends on design. So this decision is decided during the design stage. So therefore, it's also constant. So that means the two parameters here, delta L and P, are one-to-one related to each other. So if I change if I press the spring and change the, let's say, the length of the spring, so delta L, so I directly affect to change the pressure. So this is such a mechanism, very interesting, very important mechanism, actually very clever invention, design. So therefore we use this mechanism to adjust the pressure which we need inside of the machine. So it's a very simple way to adjust the pressure using the pressure regulator. You see, and if we adjust the pressure, so what is affected then by changing the pressure? What could be affected in the machine? So forces are affected, force and torques. Okay, so it's very important. You shouldn't forget it. So, okay, is there any question regarding the pressure regulator? How does it work? And the working principle of the pressure regulator. Okay, so let's continue then. You see here the I changed the laser pointer. You see the black arrows. I mean the pressure on that side, and I already explained that. So, and another unit is the air lubricator. I already mentioned it here with the lubricator, and we have here the screw, so we can adjust by adjusting the screw or turning left and right. We can adjust the amount of the oil which we inlet into the air, pressurized air. So, and the air is passing this gap and flowing in that direction, and we put some, say, coming here. So we put some oil, let's say, the drop into the air passing this narrow channel. So we lubricate the oil. So why we lubricate the oil? Why do we need to lubricate the oil in that case? Because the linear actuator has a piston inside, and during the motion forwards and backwards, so there is a friction between the inside of the piston body and the cylinder housing and the piston. So we want to avoid the friction, or we want to reduce the friction, because friction means loss of energy, force, and then the energy, of course. Okay, so this is the air distribution station. Generally, here the compressor, here we have the air reservoir and receiver, and this is the let's say the door we can use to open and clean it. And there are the indicators like the pressure, temperature, and so on. And from the air reservoir, we take the pressurized air and bring into the production or assembly area, and where we want to use in the company. And the pipes must be 1 or 2%. Let's say has to have angle in that direction, because if there is a if there is a water inside of the pressurized air, the water has to touch the bottom of the pipe and doesn't mix into the air and has to flow. So there is also here the one additional water collector. So we collect the water here. The inside of the air come from the humidity. Okay, so then if we take the oil, the pressurized air from this main pipe for the machines, let's say there's a machine here somewhere here, and we can take the pressure not from the up part, not down part. We take it out and here into the machine here somewhere. Why from the down and from the up? Because down part of this pipe can be have the water, condensed water. So okay, distribution a ring main. I mean the schematic which we can see here. The production plant in the air come say from the compressor, and you see it and into the line. This is the power units of the pneumatic energy. We can build like a ring here, and then using this ring system, we can distribute the air in the company, or we can use this type of distribution system, and this is much more say the important or desired the distribution system, because if you don't use this part, we can close here, or here we can close, and more or less the pressure and the flow rate is equally distributed. I mean, in this example, here maybe we have less pressure. We have here high pressure where we have the connections, but here we will have same pressure everywhere. Huh? So distributed homogeneous. Okay, pneumatic actuators. We discussed single acting, double acting, air motor, rotor actuator, semi-rotor actuator, and so on. When pneumatic cylinder, hydraulic, electric cylinder, okay, the actuators. Single acting cylinder we discussed, and double acting cylinder we didn't discuss. We will touch today. And the rotary motion, rotary actuators, single and double acting, pneumatic motor, hydraulic motor, electric motor are the rotary actuators in generally. And single acting cylinder, we said this is a picture from the single acting cylinder. It makes its forward advanced stroke with pressurized air, and return stroke with the spring here assembled inside of the cylinder on the piston rod, you see, because if we want to make in that direction the work, so we use the pressurized air, and if we don't make any work in that direction and in return stroke, so we use this spring because we save the energy. Huh? So and you see how does it work. Huh? So pressurized air, okay. So let's see a gap. You see, this is for the breathing. I mean, the air should come in and go out during the piston motion. Okay. So, and this is the circuit we already discussed. Also, the single acting cylinder. How can we drive the single acting cylinder? And we said that we need 3 two-way valves. So, and we discussed actually what is 3 two-way valve, and so what is 3 two-way valve and how we designed the 3 two-way valve. So all of them are we discussed. of them we are discussed. Okay, we have discussed. So the symbols of the service units you see here, the symbol of pressurized air here, source symbols. Okay. So there are some different single-acting cylinders, type of single-acting cylinders. You see, single-acting cylinders, depending on the application or the companies, they developed shape-wise or function-wise different single-acting cylinders. All of them are single-acting cylinders, small, big, and that, and these. And where we can use the single-acting cylinder or the single-acting linear actuator, you see here, if you have a workpiece and let's say we fix the workpiece here in order to process the drilling here, so then that means we have only work in that direction, in one direction. So that means the fixing of the workpiece here in the job, and therefore, so we use the single-acting cylinder. It is enough to use the single-acting cylinder because the pressurized air, that's a pneumatic force, we need only in that direction to fix the workpiece. So the double-acting cylinder, now we will continue with double-acting cylinder. Let's make a break, 15 minutes break. So 10 past 2, we will start again, okay? So can we start?
Okay, Professor, we can start.
Okay, good. So this is double acting cylinder. So double acting linear actuator. Let's say double acting exactly means double acting pneumatic linear actuator or pneumatic double acting linear actuator. So why double acting? That means this cylinder or this linear actuator can make the works in both direction. In that direction, in the advanced direction, and also in the return direction. I can show you now. So in that direction and also in that direction, or we can indicate with the, let's say we use the red one, okay. So in that direction, but also in that direction. Huh? So this piston rod execute the force, apply the force in both directions. So, and that's the reason why we say double acting. So single acting, you may remember, single acting means, okay, single acting means only in one direction, because the symbol wise, you may remember. So we have the single acting cylinder, the symbols like this, and here, okay, we have here the spring. Huh? So inside somewhere we have the spring here. So let's use the blue color and so on. Huh? So there's a spring inside, and the spring push the piston back returns by the with support of the spring. The piston makes the return stroke, and the advanced stroke is done by the pressurized air. Like here, we have to apply the pressure. So therefore, single acting in one direction. But there is also other type of, I mean, the single acting cylinders are two types. Spring can on that side of the cylinder, but also in that side. I mean, depending where where we can use it. So the other type of is like this. We have here the, let's say, in the single acting linear actually. Oh no, some moment. So I have to take it out. Where is okay, take it back. Okay, so correct. So then come to the column. Okay, so here we have the piston. Let's say piston could be here. So okay, this is the piston rod, and connect them here like this. Spring is here, so located. That means the in initial stage, the piston rod is in advanced. I mean, is the advanced position. So if we apply the air from here, then we have to apply air from here. Then after applying the air, the piston moves, make return stroke. So depends where we can use it. Let's imagine mostly the piston rod must be in advance, I mean, stroke. So then if we don't use the energy, it's supported by the spring and stay there in that position. And if we need to push it back, so then we apply the air and push it back. I mean, depends on the application. Huh? Maybe you cannot really imagine for the time being, because you need an industrial experience. But you should memorize that. You keep in memory that the single acting cylinders could be two types depending on the location of the spring. Okay, now our aim is the double acting cylinder. Okay, we know double acting cylinder. Now we are starting to let's say to check to understand double acting cylinder has also the piston here, and this is the piston rod. And the barrel, I mean, this is the barrel, piston cylinder barrel. and it's a front cap and end cap and so on. So, and if you apply the pressurized air from that side, the piston moves in that direction, and piston rod make return stroke. If you apply the pressurized air from that side, and then piston makes advanced stroke and moves in that direction. So, depending on the pressurized air where we can apply, if we apply from this port, so this has to be open to the exhaust. And if we apply here the pressurized air, then this port has to be open to the exhaust. Okay. So you see, if we apply the pressurized air, the dark blue, so piston moves in that direction, make its advanced stroke, and this port has to be open to the exhaust because the air here inside must be also exhausted. And so maybe some additional information regarding the double acting cylinders is the piston rod. I already mentioned it here. And the connections like here, you see the base end and rod end, I mean on the rod side, and or port, you can say, the connecting port. And here we have the sealing part, the red indicated in red color, sealing part. And then we have here the bearing, and this is the bearing is only in that place. I mean, in one location. So there is no bearing here, because this, the mainly supported by the spring. By the sealing piston and sealing on piston. So in order to avoid the leakage from these chambers into this chamber, so and this is not actually a support in terms of bearing. So this is just a sealing and let's say the avoiding the air passing from this chamber to this chamber or vice versa. And therefore, the piston, that means piston rod or linear action, is a linear actuator, can apply only the force or can take the load only in axial direction, not in radial direction. And the axial direction means, so also let's have the column. Okay, so this is this is axial direction in that direction, or in that direction. This is the axial direction, and this is the radial direction. So perpendicular to the axis, ax line. This is the ax line. You see, this is the ax line. This is not easy to draw a line using the mouse. So, and therefore it is not correct, but maybe this is the symmetry line, you see. And this, if force acting along this line, this is the axial force, and this is perpendicular to this direction, means radial direction. And the piston rod cannot take or cannot support the forces in radial direction, only in axial direction. In case you have also radial forces in radial direction in your design, so you have to add additional bearing to support the piston rod. So it is very important. Okay, so you see now if you check the symbol here, this is the symbol of double acting cylinder. So you see this symbol. This is the piston and piston rod, and the end cap and front cap is not really here indicated, but this, let's say, the housing or cylinder barrel. But considering this symbol, you will see now the next one type of also that double acting cylinder, and there is beside of this main piston, there is two additional piston here, like you see here, this one and this one. So 2 pistons. And these pistons are also here. You see on the design, these are the pistons. And this is, we call piston we use for the cautioning of the linear actuator. Cautioning. This is cylindric, you know, and therefore, so on. So this is the piston here, and also here we have the same. That means the piston here also, huh? Okay. So here also, huh? So we have to, okay. So the cautioning piston, cautioning. What does it mean? It means following. If we apply the pressurize from that side here, from this side, so the piston start to move in that direction, and you can see this is the beginning of the cautioning piston. If the cautioning piston arrive this position here and pass through the sealing elements here, the red one, so then the air in that chamber cannot flow here using this gap here into the atmosphere. Has to use this channel here, you see, or this channel. And this channel also a small channel. This is not usable because you see there is here one-way valve or a check valve, and therefore the valve close the channel in that direction and open in that direction. Is like the symbol wise is like this. So this is one-way valve or check valve we call it. So that means flowing in that direction is possible because the air in that direction, I mean in that direction can push this element, so, and then open the way and flow in that direction. So flow in that direction. But if a flow in that direction, so then it is not possible to flow in that direction. Why? Because the flowing air can press this element into the gap here and then close the way of flowing. So therefore, the motion of the air in that direction is not possible. So therefore, we say one-way valve or check valve. So here we have this same valve you see here. So one-way valve. That means in that direction there is no flow, but in that direction there's flow. Huh? So it could be. This is not possible here through this gap. And here we have another small channel or gap. Air can flow if this cautioning piston arrive the position, and then air has to flow using this channel. And you see there is a screw here, and with this screw we can reduce this section or increase or decrease the section of the channel. So therefore we affect the flow rate. We reduce or increase the flow rate. So since we can increase or decrease the flow rate, we increase or decrease the speed actually. And we use it to decrease the flow rate. So then piston after arriving the cautioning piston arriving this position, piston start slow down, as piston slow down, and with a reduced speed arrive its final position. So therefore, there is no crash in the final position because pneumatic is very fast, very quick, and therefore, if we drive the pneumatic cylinder without cautioning, so the end position are very affected, and that means that there is a crash, and after crashing in many times, so we damage this cylinder or linear actuator. Therefore, the cautioning. And these two pistons we call cautioning pistons, and these narrow here means it is adjustable. That means this screw we can, using here the screwdriver, we can push up and down, or we can turn up and down this screw, and by the way, we can reduce or increase the cross section, and that means we can increase or decrease the flow rate and the speed. So we adjust the cautioning in somewhere. Okay, maybe though the cautioning piston, you see in the cautioning piston is also indicated. So the cautioning adjustment screw, okay, the sealing parts you see also, and non-return valve already we discussed. So you see here what's happened now. You see, we apply the pressurizer from here. You see, let's use the laser indicator. We apply the pressurized here, dark blue, and you see the pressurizer will use this channel because this is one-way valve and it is open in that way, but not in that way, in direction, sorry. So, okay, so you see, now we have the pressure. We apply the pressurizer, but pressurizer you cannot come, so it's not possible to go in that direction. Only passing this channel can push the piston, say in the return stroke direction, and after, let's say, the leaving the cautioning piston, the sealing parts, then the full piston surface will be used for the pushing. So the maybe I'd like to see whether I have the video. Maybe if I find it, I will share with you. Cautioning. Rotors in the school of operation and position. So here. So maybe you can. Okay. You
With
see?
end position cushioning, the exhaust air is restricted during the last phase of motion. This causes a counter pressure to build up, which cushions the piston. The built-in restrictor is usually adjustable.
So can you hear the voice? I don't know whether it's the voice. The voice, is it? Oh, the voice you can hear. Okay, nice. Okay. So Sorry, no. Where is it? Here. So once more, the end position cautioning using the video, you see. So here we have the cylinders, and this is the main piston here, you see. This is the screws where we adjust the flow rate, or we adjust the cautioning. And this is the piston in front part, the cautioning piston front part, and this is the cautioning piston in return part. So you see, if the piston arrives this position, so it starts the airflow from this channel by this restricted section, and then let's say the speed slow down, the speed of the piston slow down. So let's see once more.
With end position cushioning, the exhaust air is restricted during the last phase of motion. This causes a counter pressure to build up, which cushions the piston. The built-in restrictor is usually adjustable.
Okay. So then we already learned the different, the working principle of the double acting cylinder. Also, we explained the cautioning and what is cautioning, why do we need this cautioning. So now let's come to the point where we discuss driving of the double acting cylinders. How can we drive the double acting cylinder? So we have here the double acting cylinder. Okay, you see here also with cautioning piston, adjustable cautioning facilities. So this is the symbol, and we have here in a valve, and with this valve we can drive the cylinder. Do you know this valve? So this is 5-way valve, directional control valve, symbol of manual operated spring return 5-way valve, so directional control valve. So maybe now we have to talk about the okay, driving of double acting cylinder, and therefore I'm going to use okay, the simulation software. You know that simulation software, okay. You may remember from our last lessons, we use this simulation software in order to show how can we drive single acting cylinders. And also we learned the possibilities, so to drive the single acting cylinders. This is not one. Okay, no. Okay, let's this is not what I want. Okay, I think it's okay. No, nothing. So you may remember this was the single acting cylinder, and to drive the single acting cylinder, of course, we need first of all the pneumatic energy. This was symbol of the source of pneumatic energy, and this is the, let's say, the simple symbol of the service unit. And to drive single acting cylinder, we learned actually two-way valve and three-way valve and so on. And we learned also this valve. So, and using this two-way valve, we can move the cylinders so like this, piston move forward and backward like this, so. And this position is the open position. That means the pneumatic energy is open to the cylinder. And this position is the initial position, let's say the beginning position of the valve. Initially, valve take this position because of this spring here, spring return, therefore we say spring return. So the push button, manually operated by push button with spring returns. And you see the energy is here turned off, and the pressurized air inside of cylinder open to the atmosphere. That means exhausted. So, and this valve, we said, this is 3 two-way valve. 3 indicates the ports, I mean the connections in total, and 2 indicates the number of the position. So instead of, single acting cylinder, you see single acting cylinder has only one control connections, one energy connections. So only one. So if we have, if we take double acting cylinder like this, you see this is a double acting cylinder instead of that. So how can we derive it? If we use this valve, you can see we learned already this valve. This is 3 two-way valve. If we use this one, so only one part of the cylinder can be controlled. Energy shut down or turn on or turn off. So, but there's another connections. We need also to control these connections. So what can we do if we have only 2 three-way valves? If we have only 2 three-way valves, how can we derive a double-acting linear actuator? Okay, very simple. You have to use once more, copy and paste here. Okay, so then let's start. So if I push this button, piston move forward and doesn't come back because it needs energy to bring the piston back. So therefore, I operate this valve and bring it back. So you can also remember we said this is 3 two-way valve, manually operated with push button, spring return, and normally closed. That means in normal position, that means in initial position, normal position means by spring realized position. So by spring realized position is this position, and this position you see the energy is closed. That means pneumatic energy is closed. Therefore, this is normal position, and normal position, and since the energy is closed or turned off, we say this is normally closed valve, normally closed 3 two-way valve. Okay, what will happen if if in this position, if valves are in the initial position, so I can move the piston by hand. There is no resistance because there is no pressure, whether inside, whether front side or the back side of the cylinder. So I can easily move the pistons left and right. So what do you think if I push the button at the same time? Does piston move or not? So I'm waiting for your answer. So there's no answer, huh? Can you hear me? Hello? So you don't hear me, huh? So if I push the both of the buttons, I mean this one, I push this one, and also this one, you will see the piston moves forward. So why piston moves forward? Why piston moves forward? Because we have same pressure on the both sides of the piston. Why piston moves forward? I will not give the answer here, and I will ask later. Okay, so instead of these two 3-2-way valves to drive the linear actuator, we will use another valve because it is not comfortable. It is quite difficult to use two valves. In some cases, in some applications, it makes sense and maybe bring some advantages to use these circuits, but most of the applications we use another valve, and so I will show you how can create another valve which we use to drive the double acting linear actuators. So let's so I cannot draw here, huh? Oh, so I see it is here not possible. Okay, so I cannot show that because okay, I can make, because I cannot draw here, so write something. Maybe when I use the okay. When I use the blackboard, this whiteboard, so I can draw here. So let's say this is our pencil. So we write. This is our. Oh, this is not so. What is the? No. Silky. Okay, so take it out. Okay, let's take the column. Okay, so this is our double acting cylinder, let's say, huh? This is double acting cylinder like this. Okay. So in order to drive this double acting cylinder bring in advanced position or the initial position, so we need, let's say, a valve to drive the cylinder or linear actuator. And let's think first about how many positions should have this valve. So how many positions? If you really think about, you will see we need 2 positions. And each position we can, as I discussed in our previous lessons, with square So we need two position. So the position, the first one is, let's say, the responsible to drive the cylinder forward in the advanced position, and backwards into the initial position. And the position 2, let's say this is the position 2, assume that this is the position 2, has to drive the cylinder in the advanced position, piston. So, and we can connect, let's say this valve has to have two connections for the cylinder, two output, let's say. One for this, for the back side of the cylinder, the other one is the front part of the cylinder. So then this valve has also three connections here. One is the pressurized air, we indicate with 1, and this is the exhaust part 3, and this is the exhaust part 5. That means each position has its own exhaust. So then the connections inside of the valve, if we have different color, I don't know if we have different color, maybe we have different color here, okay. So then, okay, this is connection, this is closed here, and this exhaust is open in this position of the valve. And you can easily see, if valve take this position, the pressurized air come from the port 1 and go into the port. Let's change the color once more. What is it? Color is here, okay. So that's the blue one. Here is the 2, and here is 4. So all this number comes from ISO, defined international standards, ISO 1219. So, and if I take this position, what will happen? So it is also easy to follow. As also against 5 connections, and let's first show the connections. This is the 1. This is 1, and this is 3 here, port 3, and this is port 5. This is port 5, and this is port 3. And here we have also 2 outputs. That means to the cylinders 4 and 2. Now let's think about how can we connect this port in order to bring the piston in this position, in advanced position. So then the connections inside of the valve, I mean the connections between the ports inside of the valve must be like this, isn't it? So this is, this is, so here, and this must be connected to the 3, port 2 to the 3, and this must be closed. So that means to drive this cylinder, pneumatic cylinder or linear actuator, we need a valve which has 2 positions, and each position has different function. And let's say this is the first position or the position, we have maybe with spring return here. Let's say this is the with spring return. Initial position with spring will but take this position, and this on that side we have a push button. So if we operate the valve, but we take this position. So we can, using these two positions, we create a new valve, and the new valve must be like this. So here, as our new valve will have two positions. Of course, we add these two positions together. So like this. And then I show the connections of the valve. This is the connections 4, and this is the connections 2. As you know, this, sorry, 2, or let's erase it. This is not correct here, so let's take this one, and okay, this blue one here is the 2, and here we have, as I already mentioned it, air connections. We call it, indicate with 1, and here we have the exhaust connections 3, and here we have the exhaust connections 5. So why we have two exhaust connections in this valve? Because the exhaust connections 5 used in this position, and exhaust connections 3 used in this position. So in each position we use different exhaust connections, and that's why we do that, because we are interested to exhaust the air from the cylinder as soon as possible, as quick as possible. So that is important for the speed of the piston. That means if we, depending on how fast we exhaust the air, we affect the speed of the cylinder. If we exhaust the air very fast, the speed will be very fast of the piston. So then let's draw the connections like this. Okay, the connections from so first, before we do that, so this is the position where we achieve by spring return. I'm here, and this position we achieve or we realize using the push button. So in that position, this is the initial position or normal position, let's say, because by spring will take this position. So in this position, connections are like this. So 1 is connected to the 2, and 3 is closed, as you see here, and 4 is connected to the 5, like this. So, and in this position, 1 is connected to the 4. That means to the other part of the piston, and 2 is connected to the exhaust 5, and exhaust 3 is closed. So this is the function of the valve, and we call this valve 5 two-way valve. 5 and 5/2-way valve. W is multiply, or let's raise it. So this is way valve. Okay, of course we can add the spring return with spring return or manually operated. So this is the valve we use in pneumatic technology to drive linear, double-acting linear actuators. So then let's come to the simulation software and see how can we drive the valve, cylinder, using this 5-way valve. And the 5-way valve, I have to create it here. 5-way valve, where is it? So, okay, this is the 5-way valve, I guess. Okay, yes. So I have to configure it. So we set the configuration of the valve. So we said must be spring return and not spring return, manually operated with push button like this. Okay, this is the valve, and I have to add the exhaust. Here the exhaust for the port 3, and here the exhaust for the port 5. Okay, let's close it. So this is the air connections we have to connect here. So the air connections is the 1. You see the number here, 1, 3, 4, 4, 2, and so on. Okay. So this is the circuit, pneumatic circuit. Let's start the simulation. You see in this position, 1 is connected to the port 2, and port 2 is connected to the front part of the cylinder or linear actuator. That means the piston pushed in initial position. If I operate the valve, push the button, valve will take this position. Now, in this picture, you see valve by spring has taken its position, this position, the initial position. So if I operate it, valve take this position, the second position, and 1 is connected to the port 4, and 4 means piston moves forward. And the valve, the exhaust 3 is used, in use. Huh? So if I release the force, the operation force, by spring valve take this position, and then piston moves its initial position, like this. So this is the way how can we drive a double-acting linear actuator. Double-acting linear actuator, pneumatic linear actuator. How can we drive? Huh? Okay. So we will continue, but let's make a break, 15 minutes break, and we will meet 15 past 3. Okay, we can start now. And so we were discussing the double acting cylinder. So let's think about how can we use the double acting cylinder, where we use, and how can we use double acting, that means the linear pneumatic actuators. So let's come to the PowerPoint presentation. So there is an application. We will discuss the application. So you see there is a transfer band, and we have here, let's say the package is coming from let's say from this direction, or it comes from that direction, but this direction. So I can use the laser point, comes from this direction. You see the packet says some product, let's say, and some of them has to go in that direction, or some of them has to go in that direction. So we have here a double acting linear actuator, and by operating double acting linear actuator, we can bring this transfer band in this position or in this position. So if we have, let's say if we have a box, like let's say the column here somewhere, it's box 1 or the box 2 here. Let's say here, this is the 1 and this is 2. So we realize, depending on the product, I mean, product can have a barcode, and by reading the barcode, we can identify the product, and then the system can get the necessary information whether the package has to go in that direction or in that direction. So based on this information, this double acting cylinder can bring this transfer band in this position or in this position. So you see, in both direction, the cylinder or double acting linear actuator making the work. So therefore, we have such a double acting linear actuator here. I am drawing using the symbols like this, okay, here, or like this here, 2 connections, So, and then we have here somewhere, in the system there is a valve which drives the cylinder like this here. This is the connections 2, and this exhaust port closed, this is open, and this is the port 4, which is source connected, and here the exhaust is closed, must be closed, and this must be open for the exhaust 3. So then we can connect, of course, we can connect the air like this here, and here air 1, that's mean the pressurized air, and this is exhaust. You see exhaust 3 we already learned, and this is exhaust 5 we also already discussed, connections 4 and connections 2. Okay, maybe again we use different color to make it easy understandable. Here this is spring return, the valve operation, and here we have the push button. So if we press the push button, valve take this position. If we don't press the push button, so by spring, valve take this position. So depending on the position, piston moves forward and backward. So that means the transfer band connected to the piston take the position 1 or position 2. So this interesting or nice application actually for the linear actuator. So the important is, so if we use a double acting linear actuator, pneumatic linear actuator, how can we select or how can we choose a double acting linear actuator? How can we selection or choosing? Huh? So selection, let's say selection, okay. Selection.
Hojam, are you sharing something? Because we can only see the white screen with the drawings on it.
I am using the whiteboard. Can you see that? No. Sorry, I'm using this slide. Can you see that?
No, we cannot see the slides. We can see the
You don't see
whiteboard.
that? Oh, so moment. What's going on? Then let's. So then let's. Okay. Okay. Let's use the uygulama ekran. Okay. So. Okay. Now. Let's use the uygulama ekran. Okay. So. Okay. Now. So the uygulama ekranı paylaş. So. Okay. Can you see now?
Yes, Professor, we can see the slides.
Okay. Okay, good. So we were talking about the application of double acting linear actuator, pneumatic linear actuator, and we said there is a band system, transfer band. So we have some product on the band and moving in that direction. Let's say the column, and then the motion direction can be, so they are moving in that direction. Huh? So in that direction. Okay. So, and then we have, let's say, two different products, product 1 and product 2. Product 1 has to go in this station, and product 2 has to go in this station. Huh? So, and here we have a movable additional transfer band, which is connected to the first one, and this band by the double acting linear actuator can take two positions. In advanced position is the transfer band is in that position, take this position. In initial position, take this position. So therefore, the goods coming from the the main band can go in that direction or in that direction. And there is a, let's say, the sensor here read the barcode and get the system, get information, which type of product is it, and it has to go in that direction or in that direction, getting this information. So this the cylinder can be driven or driven in that shape. It can be actuated in that position or in that position. So this is the application we were talking about. So for that reason, to drive this cylinder, that means to bring this band in the position first and position 2. So we use a double acting pneumatic linear actuator. And to drive this linear actuator, we use the 5-2-way valve we learned already. And the 5-2-way valve, okay, here we said with spring return and push button operated, but if we automate the system, so push button is not actually ideal. So that means we have to, what's that? Why I cannot use it? So I can drive, okay. Let's Let's see again. Okay. Oh, I cannot raise it. This is interesting. So, okay. We must be a solenoid valve. I mean, we have to actuate or operate the valve by using the electric signals. Therefore, we need a solenoid valve. But nevertheless. So, okay. Our double acting cylinder we use to move the second part of the transfer band in that position or in that position, and by changing of the position, so the products coming from this main band can go in that direction or in that direction to the station 1 or to the station 2. 1 or 2. Okay, so then we said, how can we select double acting cylinder? What is the main criteria we have to consider by selecting of the double acting pneumatic linear actuator? So selection. So we said, okay, what could be? What do we need? What do you guess? First of all, I guess we need the force. Huh? How much force we need to move this part in that direction or in that direction? First, the force is important. Huh? F force. So we have to know. So how much? Second, actually, second is the the length of the motion, isn't it? So this is the, I mean, if you say delta S or delta L, the length here, move from the initial position to the advanced position or vice versa. So, and this L is very important. That means for us, delta L is the stroke. Huh? So two important parameter or two important factor we have to consider: force and distance has to move. So force, if we say force, how can we calculate the force? So F is equal area times pressure, isn't it? We already learned that. Area times pressure. What is the area here? This is the area here. The area you see here, this is the one of the area. Let's say A1 here. A1 is this one, the back side of the piston. And the second part is this one, A2, let's say, A2. So A2 seems like that because the two area are different. A2 seems like that. This is the area of the cross section of the piston rod. Huh? So the effective area is this one for the force creation, and this area is the full section, total section of the piston, like this. So, and we can easily see here that A1 is bigger than A2, isn't it? A1 is bigger than A2. And that means the force in that direction, let's take the color red. So the force in that direction is F2. Let's say this is the F2. And the force in that direction let's say F1, are different, not the same, since the areas are different. So that means F1 pressure is the same. Pressure is the same. F1 is bigger than F2. So, okay, this is also clear. So how can we calculate the F? So let's say the F1. So in order to calculate the F1, let's turn black 1, okay. F1 is equal A1 type P. So instead of P, P is pressure coming from the pressurized air. So the A is actually the diameter, isn't it? Piston diameter. Depends on the piston diameter. So D. And then we can write here A is equal pi times D over 2 square. Like this. So this is the area. And times P, of course. And the unit of P is Newton per meter square. Newton per meter square. This is the unit of P. And here the unit is of area is meter square. So, and F is of course Newton. So the main parameter to define the force is actually what here? What is the main parameter here? To define the force? Is D, diameter. So that means we should know the stroke delta L is stroke, and the diameter, piston diameter D. So those are the important parameters we need to select a double acting linear pneumatic actuators. Because we need force, and for the force we need diameter. Using the diameter we can calculate the force, because the pressure is already constant, 546 bar, not more. In pneumatic we use 546 bar, and therefore we consider that the force is constant, and then only diameters we can select, and diameters are standardized. It starts, they say, diameter D is like 6 or 8 or 10 or 12 or 16 or 20, 25 and 30. Let's come here. 30, 25, just 30, I guess. 40 and 50 and 63, 62, sorry, I can, if I remember well, and the 80 and 100 and so on, and 100 and so on. It goes in that direction. The maximum 125 or 100, 150 and so on. So not too much. And this is standardized. So we have to calculate the force or if we know the force we need to move this part. So if you know the force, so we can calculate easily the diameter, isn't it? So diameter is equal. So if we say here the force, we know the force F is equal, let's say F is equal F, so pi and d square over 4 times P. So then d square is equal, or d is equal square root, we say, square root 4f, 4 times f over pi times P. Pressure is the diameter, isn't it? Is the diameter. So we can calculate diameter. Of course, force has to be calculated in Newton, and P pressure Newton per square meter, and then we have the diameter in meters. So we have to convert in millimeter because those are all millimeter, not meter here. So all the standardized values given in millimeter. So then stroke is also given in millimeter, but you cannot insist on a different diameter because it's not available in the market. But you can insist on, let's say, the certain stroke, because some companies can produce a cylinder for a special stroke. Company owns special strokes, but not the diameter, piston diameter. Okay. Any question? If not, so then we continue. Now I'm going to talk about the actuators. There are different type of linear double-acting actuators. So actually we discussed, so what is double-acting linear actuator? How can we select double-acting linear? We don't produce double-acting linear actuator. We don't produce. Why we don't produce? Because there are some companies producing such type of product and there is no need to produce it. And they are specialists about the production of the double-acting or single-acting linear pneumatic actuators and all accessories actually. But it is not forbidden. Of course, you can produce, but you cannot produce as let's say qualifies. Say this is difficult actually. They are expert and they know much more than say the machine producer or any producer. Actually, not the main business unit. They are main business unit, not the pneumatic linear actuator. So in machine design, we also discuss in the machine design, our machine design lessons. So you have to use as much as possible standard product in machine. Because if you use special product, that means special product you produce in your company, so the customer will not buy this machine. Because this part you produced and put into the machine, if let's say later on customer will have any trouble with these products, so they cannot easily replace this product. They cannot find the product and replace. So machine will stop to produce, and the customer will lose lots of money. Product means also money. So they will select, they will insist on that you use as machine producer, use standard product in your machine, so that the owner of the machine, that means the customer, can find on the market the standard product and very quick and very easy replace it if the machine stops to produce because of any failure, right? So because of the, let's say, the failure of the product used in the machines. Okay, so another important part is if you use the linear actuator, pneumatic linear double acting actuator, of course the connections part of the linear actuator. So how you are going to fix it, and the connections parts are also very important, and some of them are standardized. There are some standard cylinders, ISO cylinders we say, ISO Standardized and International Standardization Institute, standardized. That means the standard connections, say the connections dimensions. And this is also important to consider, because any other not standard connections dimensions will not fit fit the let's say the interface from the machine, and therefore it will create another additional problem, which is not necessary actually. Okay, let's continue with the types of linear actuators, pneumatic. So we have also double acting linear actuator, we call tandem double acting linear actuator or double acting cylinder, tandem type. What means tandem? So you can easily imagine that we said, okay, we need force, huh? We need force, let's say in that direction, so, or in that direction. And the force we can define, we already talked, force we can defined. In that way, F is equal area times piston, cross-section area times pressure. So pressure. Okay. So in this double acting linear actuator, you can see there is two pistons, and I will indicate them using the yellow color. The first one is this one here. You see this one, okay, and the other ones here. So if we apply the pressurized air from here, we can create a force using this part of the piston, this cross section of the piston like this. I can show you, take the column, okay. So you see piston section here, and this is like this, eh? So, because to create the force, since the pressure is constant, P is constant, our main parameter to change the force or to increase or decrease the force is the area here by design. So it's during the design stage. Huh? So you see, I use in this cylinder two pistons. One is here, the other one is here. You see. Eh? So the other one is here. This one. So this piston, you know. And we have another section here, cross section here, like this. But there is a area inside which is not used This is the area of piston rod, cross section of the piston rod. But here we have A1, and this is the, let's say I use different color. No, I have to take out, maybe it's better. Where is this here? So take it out. So I will reuse it. Okay, here the piston rod, and the effective or used area is this one here. So let's say this is A2. So A2, it's also nice now. Okay, here, column A2. So you can imagine if we apply pressurized air from here, from that port. So we use this section A1, and we use, and if we apply pressurized air at the same time from here, we use two sections, A1 and A2. I mean, then our force in that direction, is calculated like F is equal A1 plus A2 times pressure. So that means we increase the force, isn't it? We have two sections here, cross section coming from the pistons. That means two pistons are integrated, coupled. So therefore, we increase the area, and since we increase the area, we increase the force, because pressure is more or less constant, 546 bar. So this type of cylinder we call tandem cylinder. Tandem cylinder we use in order to increase the force. If we need more force, so we use those type of linear actuator, double acting linear actuator, to increase the force. Okay. So, and this we call tandem cylinder. You see the symbol here of the tandem cylinder. Okay. Of course, if we apply the pressure from this here, from that, and from here and from here, this is from, let's say, from, this is the 1 and 1 here, and this is, let's say, 2 and 2, because the same time piston moves backwards. It's in its initial position. So we use this section here, and this section is, of course, so not full section of the piston area. It is, let's say, the smaller, as small as the section of the here piston rod, and he is also as small as the piston section here. But we can easily create in forwards motion quite big force. So you can, there are many applications in the industry. We use sometimes not two piston, maybe 3 or 4 piston connected in short stroke. In pneumatic press, for example, pneumatic press applications, because you can increase really the force, and pneumatic press is very easy application, and in some application very useful. So, you know, the hydraulic is in that case not needed, because of the force is not high, but if we need a really higher force, then we use hydraulic or we use eccentric press. Okay, let's continue. The other, this is the tandem cylinder you see here. 1, 2, 3, 4 cylinders are connected. That means 4 pistons are connected like this. This 1, 2, 3, 4. And here you see, for example, 2 pistons are connected, 3 pistons are connected, and 4 pistons are connected. 1, 2, 3, 4. That means the force is 4 times increased, but not, I mean, the cross area is not the same. Here we reduce cross area because of the piston rod, and here the same, also here the same, but here we have the full piston area. But nevertheless, the force, if we calculate the force here, you can see the column here, the force is equal here, the area increased A1, here A1 plus A2, and plus A3, and plus A4. 1, 2, 3, 4, plus A4, 4 times pressure we use in the pneumatic. And this is here A1, this section here, this is the A1, and this is A2, and this is A3, and this section is 4. So this is the 1, and this is 2, and this is 3, and this is 4, you see. And 1 is full area, piston cross section, full section. And 2 and 3s are like this. So there is a piston rod inside and is somehow reduced. So this is not nice indicated. I have to take it out and redraw it once more. Like this. So, okay. We already discussed in our previous example. This is A1, and this is A2, 3, and 4. The same. Okay. So, by the way, we can increase the force. And I have seen and I apply in many companies, so pneumatic press in such a way. So there is another actuator we call double rod, double acting cylinder. It's also double acting linear actuator, but you see the piston rod we have on the both side piston rod. On that side, here on that side, and also on that side we have piston rod. So there is interesting properties of this cylinder. So you can easily imagine the piston here in the middle. This piston, these are also the piston rod, and the cross section. We have same cross section on the both sides. We have cross section here on this side, and also the cross section this side, same. Not about hence it's not. I cannot read. Drawing is very difficult using the mouse. This is my difficulties, but I will try much more. It's like an apple, huh? So, and here, so you see this section, And the same here, huh? So what does it mean for us? We have same force on the both sides. Huh? Here F1, also here F1 force are same. Because pressure is same, areas, pressures are same, areas are same on the both sides, so we have same force. If we need same force on the both sides, we have to use double rod, double acting linear actuators. Okay. So another application of these double acting linear actuators, the multi-position cylinder, to create a multi-position cylinder. So multi-position cylinder. So what we can do, we do following. So two cylinders are connected together. This is the first one here, the second one are connected on the back side. And then let's say we have here, we fixed it here like this. Fixed the piston rod here, and the piston, the linear actually, sorry, a moment, wait. Okay, the body of the cylinders is movable on a certain bearing system here, can move horizontally. So let's imagine these cylinders are in the initial positions. That means this is in this position, the pistons, we have the position 1. So the position 1. So if I apply the pressure for the piston, pressure air piston, this is say the 2, piston 2, say piston 1, and this is piston 2, or piston 1 and piston, let's say this is, let's use this, the 2. So 2. So then I get this position here. And if I, so get this position, if I apply the, okay, if I apply the pressure here and not here, I have the position 2. This is not correct indicated. So this is position 2, and this must be, okay, it could be also, that means they all have the same stroke. If they have same stroke, so the position, then if you want to create the 3 positions, okay, same stroke, 3 positions is also possible. So, and if we apply the air in both linear actuator, so then I get the position 3. But actually, 4 positions are possible. That means I can create 4 positions. Position 1 is the initial position for the both cylinder. Position 2, the cylinder 1 is, I'd say, the active, and position cylinder 1 is active. Position 3, cylinder 2 is active only, and position 4, cylinder 1 and 2 is active. That means derived. So I can realize 4 different positions. That means multi-position cylinder This is a type of application, okay? In order to create some position, fixed position. There are machines, maybe it is difficult for you to imagine, but there are machines, and in the machines there are some units, and these units are responsible, say, to bring certain components in certain position, and therefore we use this type of solution to create multi-position. But if we use two cylinders connected together, we can create maximum 4 position, not more. Okay, so let's make a break, again 15 minutes, and we meet a 6:15, and we finish our lessons today. Do you have any question? Okay, if not, so this is a cylinder actually, the multi-position cylinder, but we will discuss. Okay, now let's wait, we will discuss, okay, in our next lessons. Okay, can you hear me? We can start now. Our last lesson for today. Can you see the slides? Hello, can you see the slides? Okay, then we start. So we were talking about the multi-position cylinder or multi-position linear actuator, and we discussed how can we create multi-position. So another example is this one. You see here, if we want to create four different positions with two cylinders, it's possible actually. Of course, with two cylinders, we can maximum four different positions we can create. So the first position, if you fix here the piston, I will show now. So let's use the okay, right, and here use this one, and okay, let's fix the piston holes like here. We fixed it here. So there's no motion in that direction. The motion is only in that direction. So in that direction. So this is the initial position of the cylinder. There's two cylinders here connected, as you see here. The two cylinders on the back side to each other. So in this position, in initial position of all the cylinders, we have this position 1. Let's say here's the position 1. So, and if the position 2 and and we know that these two cylinders can move on this surface horizontally. Horizontal motion is possible. So, okay. And if we apply the pressurizer for the cylinder 1, let's say this is the cylinder 1 and this is the cylinder 2 or linear actuator 2. If we apply for the 1, the pressure is there, it moves in that direction, take the position 2. This is the position 2. So, and if, let's say, bring this first cylinder in initial position and advance the position, the second cylinder, because they have different stroke, then we achieve the position 3. And if we apply pressurized air to both cylinders, that means the two cylinders are in advanced position, advanced stroke. So then we have the position 4. So 4 different position. Position 1, 2, 3, and 4. Okay. So it's also used in industry. But sometimes they make mistake, and today's I faced one of them in the company, and I said, it is unbelievable. I mean, they say misdesign, or let's say the design failure, right? So we correct it now. So this is the reality. I mean, you see the two cylinders here, two cylinders, cylinder 1 and 2 are connected to each other here on the back side. So, and let's say if you fix these cylinders here and apply the pressurizer, this one, we take the second position and then the third position, and if you both of them, fourth position, and so on, like we discussed in the previous slides. There are also rodless cylinders. Rodless, we say, rodless linear actuator. There is no piston rod, like this here. Here, this is cylinder with piston rod. You see, there is inside piston and piston rod. But there are also different type of design of linear actuator, pneumatic linear, double acting linear actuator, and this is not, it's not piston rod. So how does it work? We will discuss now. You see, if a piston rod, so extend in that direction. So, and if you have a rodless cylinder without piston rod, that means needs less place. So like this, takes less place. So conventional double acting linear cylinder or linear actuator requires space to house the cylinder plus space to carry out the work, I mean the stroke. So the more effective use of the available space can be made by using rodless cylinder, because rodless cylinder needs place, let's say the half of the double acting linear actuators needed. So the rodless cylinder mechanically coupled, so you will see now the bodies of the cylinder and profile of the cylinder. Here you see, and this is the piston here inside, here move in that direction, and piston is connected to this part, and this is also connected to the clamp for seal and the protections via this protection strip. So piston and carrying assembly. So here the piston and body of cylinder is here, and the internal seal, of course the internal seal here you see, and the protection strip here, over here the red one, protection strip. So, and the end caps here, one's here, the other one is here, and there is no piston rod. So piston is free inside of the cylinder. It is in cylindrical shape, so moves. If we apply the pressurizer from that side, moves in that direction. If we apply from that side, moves in that direction. Since the piston is connected, mechanically connected to the to this part outside of the cylinders, so connected, we have of course the sealing parts here and protection part and protection strip and sealing part. So there is no, I cannot, it's not possible to say no leakage. There is leakage, but in tolerance, in the acceptable tolerance. So the cylinder seems from the outside like this. This is the moving part on the cylinder, which is connected mechanically from the with the piston inside of the cylinder. And there are different type of design regarding the rodless cylinder. You see this here. This is the simple one, basic design. This is with slide bearing guide. We have the slide bearing guide, and we have here with recirculating ball bearing guide and so on. So because of the loading situation, so where we apply the cylinder linear actuators, so there's load or torque, maybe the load, I mean the force or torque. So, and the design has to carry out the load, external loads, therefore different designs, especially regarding the bearing. So now you see the end caps, rodless cylinder, magnetic. Sorry, this is another double acting linear actuator. So you see this is a tube here, like pipe. So and end cap here, end cap here. This is also rodless cylinder, but magnetically coupled. So there is no mechanical connection between connection between piston and the outside part outside moving on the piston or on the cylinder. It's a piston magnet packet here. We have the magnets here inside of the cylinder. This is the piston, and those are the sealing parts here. On moves in that direction, that direction, depending on which direction comes from the pressurized air. And the other magnet packet is outside of the cylinder. and the part, outside part on the pipe or barrel of the cylinder and the inside piston are connected via the magnetic force. So that means there is no direct connections, there's force connections, and these force connections, force-based connections, and force are the magnetic force. And those are the, let's say, natural magnets, not electrical magnets, not solenoid like. Okay, you see the effects of the magnetic field and the connections coupling via the magnetic force. So those are the cylinders we see from the outside. So this is unit pipe, and the piston is inside of this pipe, or okay, pipe, inside of the pipe. This is a piston, and outside is the moving part. Or we can use it by applying the bearing system, additional bearing system, if we need. If there is the torque, for example, has to be carried out by the linear actuator, or force not in radial direction, not in axial direction, radial direction, and so on. So we have to apply the external bearing system. So another type of actuators, not linear actuator, this time is the rotary actuator. So we already mentioned it at the beginning of our lessons regarding the actuators. We said pneumatic actuators we can divide in two parts: the linear actuators and rotary actuators. And rotary actuators can be divided in two parts: fully rotary and semi-rotary actuator, and so on. So here we have the rack and pinion rotary actuators, actually the semi-rotary, not full rotary actuators. Like this here, rack and pinion, you see here, this is the pinion you see, and drive shaft with gear connected here, and this is the body of the actuators, and there is a pinion. Pinion is here and rack is here, and so on. This is the piston with rack arrangement here. And if we let's say apply, this is also the piston here. If we apply pressurized from here or from here, you can imagine this is a piston, type of piston, moves in that direction, and this moves in that direction. And since they are in contact with the gear here, gear connections, so the gear in between is the pinion. So pinions start to create a rotary motion. That means we convert actually the linear motion into the rotary motion using this rack and pinion rotary actuator. And rack and pinion is also mechanic system. So used in the design, machine design, and as a solution, mechanical solution, to convert the linear motion or the rotary motion in linear motion, or linear motion in rotary motion. So the cup here, the end cup with shock absorber type cushioning adjustment. Shock absorber is also needed because at the end position, because of the speed of the actuator in end position, it creates noisy crash and so on. In order to avoid that, we need shock absorber or the end cap cushioning. And also the other part, the second part, end cap with pneumatic connections. So these are the pneumatic connections and pressurized air connections. Okay, if we apply the air from here, you see it moves in that direction. It moves in that direction. Of course, we apply at the same time the air from here and air from here. Huh? So that this piston moves, this piston moves in that direction, and this moves in that direction. So since the both pistons are moving in that direction because of the gear connections here. This is the rack and this is the pinion. So pinions start to create or to provide rotary motion. And this is a symbol of this. You see the symbol there. Okay. So this is the real picture of the rack and pinion rotary actuators. And this is the part where we get the rotary motion. And inside are the pistons, and we connect the air like this here. We create the rotary motion. That means we convert the linear motion into rotary motion. Those are the cushioning part of the shock absorber. There are another design like this. So this is also rack and pinion rotary actuators, different design. We get the rotary motion from here. It seems like this. So this is also different design, as you see here in the picture. This is the pinion, this is the rack, and if we apply the pressurized air and the piston moves in that direction or in that direction, we convert the linear motion into the rotary motion. And there's another type, vane type rotary actuator. Also the same semi-rotary is much more correct because not fully rotate. And this is vane type, that means there's vane here. So we apply the air from that and turns in that direction or in that directions. Like this, here you see if you apply the pressurized air from here, it moves in, so turn or rotate in that direction. If you apply the pressurized air from here, will rotate in that direction. Like this. So, and there are also another linear and rotary actuator, linear rotary combined. That means it creates a screw type of motion, linear and rotary at the same time. So there is also those type of actuators because in industry we need in some application rotary and linear motion at the same time from the same actuator, and for those type of application we can use this product. So the inside of the product is like this. So we have here the rotary part and we have the linear part. That means actually two actuators are connected, the rotary part and the linear part. So you see the symbol here. Linear and rotary actuators combination. So we can, in order to create a different solution, which we need in the design, machine design. So we can combine all these actuators in a different way in order to create our desired solution. So you see here the linear and rotary motion at the same time, linear rotary motion for different applications. And there is also air motor, piston type of air motor. That means we create full rotary motion, and you see it's like a crank slider mechanism. It's the crank slider. Inside is the crankshaft and it's the slider piston. So using the pressurized air applying to the piston, we create here the linear motion, this linear motion, while the piston, PL, and the crankshaft converted into the rotary motion. So this is the air motor. You see this section, air motor. And there's another motor, air motor, the vane type of motor. I mean, here's the supply for clockwise running. So we can we can create two different motion, I mean direction-wise. So it is clockwise, this is counterclockwise. So let's use the laser. This is the clockwise, this is counterclockwise. And this we call vane. And here air outlet, air inlet for the counterclockwise direction. This is clockwise direction, air inlet supplied, okay? And this we use to create the linear rotary motion. So there are some application using these all actuators. So high precision guidance units. So linear actuator, rotary actuator, semi-rotary actuator in a certain combination and so on. Cartesian system we can use. You see the simple robots we can build a simple robots, pneumatic robots. It's also possible. So another topic is how can assembly the linear actuators into the machine, because linear actuator by itself doesn't mean anything. So we have to use in a machine. So machine, you know, the machine from definition to do the work, we need the machine. And the machine, in order to do the work, needs many motions. Some of them are linear, some of them are rotary, some of them are semi-rotary or in in combination. So, and therefore we use those type of actuators, but somehow we have to fix the actuators into the machine. So there are some possibilities. Center swivel flange, for example, we use, or rear swivel flange like this, or front mounting like this, or front flange like this, or rear mounting like this, or swivel flange like this, or the front swivel flange or rear flange and so on. There are different type of possibilities to connect, to fix the actuators in the machine. Okay, so now we finished the actuators, pneumatic actuators. So we finished the pneumatic actuators. Okay, we have to take out. Oh, I have to take out all of them. Oh, no. Okay. Oh, there are many. Okay, it's also good. Okay, maybe I can show you some some videos and the finish for today regarding the actuator, pneumatic actuators, the application, and the function, and how does it work. Okay, where is it? Maybe here. So rodless, rotary linear, for example. Rotary linear actuators.
The piston rod of a rotary cylinder has a tooth profile that drives a gear wheel. This handling device uses a rotary drive, with the rotary motion being produced at the center of the cylinder.
You see the application where we can apply or how can we use, huh? Okay. And rotary vane, for example, is another app.
Smaller forces and compact dimensions are needed for this screen wiper on a CNC machine. Here's another pneumatic rotary drive that has proved to be effective, the rotary vane cylinder.
Okay, rotary vane cylinder and rotary vane cylinder application too. There's another application, rotary vane.
Here a rotary vane cylinder is being used to power a swivel arm. And here for turning workpieces.
So you see, we need semi-rotary motion, we need linear motion, all those type of motion, I mean, created by the linear actuator or rotary or semi-rotary actuator needed in the machines. In mechatronic system, huh? So another video regarding the actuators.
In a rotary vane cylinder, the energy of the compressed air is converted directly into rotary motion. The compressed air acts on the rotary vane. The rotary vane transmits the force to the drive shaft.
Okay, this is also another application. So another application regarding the actuator.
A single acting cylinder is made up of the following component parts.
We learned already.
The base cap.
Okay, I forget it.
The bearing cap.
Maybe did you? I
The
don't
cylinder
know.
barrel.
Okay, let's repeat it once
The
more.
piston and seal.
Mm-hmm.
The piston rod. And the return spring. A distinction is made between the piston side and the rod side. There must be no pressure buildup on the rod side during the forward stroke, which is why there is an exhaust hole in the bearing cap.
Okay. So principle of operation. This is not needed. Process CD. So 5-2-way valve, how does it work? I'm in the way of double acting plot operation. Principle, principle. Okay, let's see the valve we use to drive the cylinder.
In the normal position, the piston slide in the valve housing allows compressed air to flow from 1 to 2. Port 4 is exhausted to port 5. When the piston slide is reversed through actuation of the valve, the compressed air flows from 1 to 4 and the cylinder piston advances. At the same time, the exhaust air from the cylinder's piston rod side flows via port 2 to exhaust port 3. When the valve is no longer actuated, the piston slide is again reversed through the reset spring, and the valve returns to its normal position.
Okay. And another video regarding 5-2-way valve.
Again, a 5-2-way valve activated by compressed air is used as final control element. But this time, a short signal is enough to reverse the valve. Since the valve has no spring return, a short compressed air signal at pilot port 14 is enough to reverse the final control element. For resetting, the valve has a second pilot port 12 on the opposite side. Here too, a short compressed air signal is sufficient.
So you see, to operate the valve, operate the valve, we apply two different signals, 12 and 14. But air, I mean pressurized air we use. That means 12 means if we apply the pressurized air, I mean here signals to operate the valve. So 12 means 1 connected to 2. Huh? So if we have pressure signal 12, that means 1 has to be connected to the 2. If we apply the signals 14, 1 means the 1, that means the pressure is connected to 4, like this. Huh? So this is the meaning. But in the case we use the solenoid valves, instead of the pressurized air here as signals to operate the valve, we use the solenoids, and solenoids, as you know, will be actuated by the electric signals, and you know the electric signals create the electrical electromagnetic force, and using the electromagnetic force, the piston inside or the slider inside of the valve will be actuated. This is actuated. Okay.
As 2 pilot ports are used to switch this valve, it is called a double pilot valve.
Okay, applications, roller level applications. So so maybe one thing I have to mention. So we talk about the force and distance. I mean, how can we adjust the force, for example, with distance? So how can we calculate the force? And we already calculate, we always learn how can we calculate the force and how can we calculate, or the actually speed we didn't mention, but speed is also easy. If you know the stroke length, and stroke length divided by the times, we can calculate the speed of the cylinder. And to in pneumatic linear actuators, to change the pressure is quite easy. We turn left and right using a screw mechanism. We can adjust the by pressure regulator. We can adjust the pressure. So by adjusting the pressure or increasing, decreasing the pressure, we can adjust the forces and all the forces and torques. And we can also change the speed of pneumatic actuators by changing the flow rate. And for that reason, we use the flow rate control valve. That means we can reduce or increase or reduce or increase or decrease the cross section of the pipe where the pneumatic energy flow through. So then if we increase or decrease the flow rate, we affect the speed, actually velocity of the actuators. So both of them, to change the pressure and to change the velocity, are very simple and very easy in pneumatic system. Therefore, we use also these possibilities or these facilities which pneumatic system offers to us. Very comfortable. We can change speed and the pressure, speed and forces. So this was another important, let's say, facilities we use. But you know, since we have restricted pressure, or let's say the limited pressure, like 5 bar or 6 bar, so to increase the force, we have to increase the area of the, that means area, that means we have to increase the piston diameter. And if you increase the piston diameter, so you see it needs more place, and sometimes we don't have such a place. So if we need more force, which we cannot create by a pneumatic system, then we change the technology. We use the hydraulic. So hydraulic, you know, hydraulic system, we will talk in our next lessons about the hydraulic actuators. So hydraulic actuators we can create using the hydraulic actuator much more higher forces. Why? Because we have high pressure in the hydraulic actuators, very high pressure. That means it starts from 20, 40, and then continue with 80, 100, 200, 400, 800, and so on. 600 bar. This is quite high. So in a, let's say, small size of components like double acting, single acting cylinder, or rotary actuator like hydromotor, we can create quite higher torque or forces. Okay, I think it's enough for today. See you next week. And we will continue with the hydraulic actuators.
Take care, Professor. Bye.
You're welcome. Bye bye.
Hocam slaytları paylaşabilir misiniz?
Efendim?
Slaytları paylaşabilir misiniz?
Tabii onları paylaşacağım ben sizinle. Evet, onları paylaşacağım. Bununla ilgili kitap yok. Dolayısıyla bu benim hazırladığım şeyler Festo'nun yardımıyla, Festo firmasının. Dolayısıyla onları sizinle paylaşacağım o slaytları. Tamam?
Teşekkürler hocam.
Okay, rica ederim.
Hello, Hocam.
Hello.
I'm just asking because this is my first class. Do we have any homework or assignment to?
Yes, you will get homework, but next week we will talk about, I guess, because this week I don't have all the students. I see there is 9 or 10 students are participated.
Yes.
So I hope next week we will discuss about the homework. Okay.
Okay. Thank you so much for your time.
You are welcome. You are welcome. Have a nice week.
You too. Bye bye.
Bye bye.